All right, I will assume that if you are here, that means that you have completed your quiz and you are ready to start the classwork. So the first thing that we need to go over today is that a square root is the inverse operation of a square. So when I say take the square root of 25, we know the answer is 5 because 5 times 5 is 25. Or another way to say that is 5 squared is 25. And when I take the square root of a square, square root cancels square, and I'm just left with 5. Hopefully you covered that back in middle school or Algebra 1. Another example of that being that the square root of 1 is just 1, because 1 times 1 equals 1. But here's the new piece. Square root of negative 1. The problem is we don't have a number that when you multiply it by itself, it equals negative 1. If I do 1 times 1 is negative 1. Or sorry, 1 times 1 is 1. If I do negative 1, negative 1 times negative 1 is still 1. We don't have a number that I can multiply by itself to be negative 1. So mathematicians invented this number. It's the number I, which I know sounds silly. I stands for imaginary because it is an imaginary number. And if this is something you are interested in, I have some really cool YouTube videos about where I came from and how it helped them and what it did. But the bottom line is I is the square root of negative 1. That means I times I equals negative 1, or I squared equals negative 1. I always put the little curly Q at the bottom of my I, partially because I learned how to write by writing cursive, and partially because it just differentiates it from a 1 a little bit more. But as long as your writing is legible, you can write your I however makes sense for you. So we're going to use that fact that I squared is negative 1 to complete some problems today. The first set here is just review. If I knew what the square root of 20 was, I would just write it. Like up here, I knew the square root of 25 was 5. But the problem is, I don't know. 20 is not a perfect square. So hopefully, sometime in your math career, you learned how to factor a number like this. And you probably learned one of either two ways. You either learned to say, all right, 20, and then pick two numbers that multiply to 20, like maybe 4 times 5. And you said, oh, 5 is prime, so I can't go any further there. But 4 can keep going. 4 is the same as 2 times 2. Okay? And then we could say, all right, well then 20 is the same as saying the square root of 20 is the same as the square root of 2 times 2 times 5. And 2 times 2 is the same as saying square root of 2 squared times 5. And then maybe you remember from Algebra 1 the rule that you can split your radical. 2 squared times root 5. I don't know the square root of 5. It's not a perfect square, it's stuck. But this is a perfect square, 2 squared. The square root of 2 squared is just 2. The square root sign canceled my exponent, and I get 2 square roots of 5. That's one way you might have learned it. You also might have learned it using the ladder method. You might have said, all right, here's the number we're factoring. Let's give it a nice little ledge to stand on. And then we said, what's a number that goes into 20? We're only allowed to pick prime numbers. When you make the tree, you can pick any numbers you want. But when you make the ladder, you can only pick 2, 3, 5, 7, 11, etc. They have to be prime numbers. So the smallest prime is 2. 2 goes into 20. It's basically an upside down division now. 2 goes into 20 10 times. And I make a nice little step on my ladder for 10. I now need to divide a prime into 10. Oh, look, again, 2 goes into 10. 5 times. Give 5 a nice little ledge to sit on. 2 doesn't go into 5. 3 doesn't go into 5. but 5 goes into 5 one time. Some people call this the upside down birthday cake because you always know you're done when you put the candle on the cake. So what we did again is we rewrote root 20 to be 2 times 2 times 5. These are my factors. And I could write it all out again. I could say, hey, square root of 2 times 2 times 5, and it would be the exact same pattern here. But you also might have noticed a shortcut. Anything that has a pair is going to end up on the outside. So since I have a pair of 2's, that's on the outside, and the 5 doesn't have a friend, so he's on the inside. It doesn't matter if you like to factor using the ladder or you like to factor using the tree, you still get to the prime factorization of 20 is 2 times 2 times 5. So let's try another one. Let's do root 45. Suppose you like the tree better. Then I'm going to say, all right, well, I know that 45 is 5 times 9. Maybe you wanted to say it's 3 times 15. Doesn't matter. You're going to get the same answer. 5 is prime. 9 can still split into 3 times 3. Oh, those are both prime now, so I can't go any further. So I've rewritten this to be 5 times 3 times 3. Or 5 times 3 squared. Well, I know the square root of 3 squared. 3 squared is 9. The square root of 3 squared is just 3. The 5 doesn't have anything to simplify. Square root of 5 is an irrational number. So that is my final answer. And if I use my trick here, look, there was a pair of 3's. They're going to be on the outside. 5 doesn't have any friends. He's on the inside. All right, you pause the video. See if you can try this last one on your own, and then come back and see if you got it right. All right, let's do this one with the ladder method. Let's say that I wanted to factor 300. You could have factored it using the tree. There's nothing wrong with that. I'm going to say, does 2 go into 300? Yeah, it does 150 times. I make another rung of my ladder. Can I divide 2 into 150 again? Sure can, 75 times. 2 doesn't go into 75. So let's pick the next prime number. 3 goes in. 3 goes into 75 25 times. Give it another ladder. 3 does not go into 25. The next prime number is 5, which goes into 25 5 times. And the only number that goes into 5 is 5, and there's my birthday candle. So I know that I'm done. Now if I take my shortcut and I say, hey, here's a pair of 2's, here's a pair of 5's, the outside is going to have a 2 and a 5, and the inside is going to have the 3 that had no buddies. So I multiply these numbers together, and I get 10 root 3. Okay. All right, now let's look at stuff that has negatives. So here's the deal. We can't take the square root of a negative. We don't know what it is. So this is where that I is going to come into play. I am first going to rewrite this. I'm going to say, all right, well, the square root of negative 12 is the same thing as the square root of negative 1 times the square root of 12. I just factored out that negative because I don't know what to do with it. I know how to take the square root of 12, but I didn't know how to take the square root of negative 12. So now I'm in luck because I know what the square root of negative 1 is. We defined it way up here at the beginning. The square root of negative 1 is I. So I can say, all right, well, this first radical is I, and now I need to factor the second radical. 12 is the same as 4 times 3. You could have said 6 times 2. That's totally fine. 3 is prime. 4 factors into 2 times 2. So I know that a 2 is going to come out because he has a buddy, and a 3 is going to stay behind. I also have this I that's coming out. So on the outside, I have I have 2, and I have a root 3. We don't usually write I2 because that's awkward, so you'll rearrange it and write 2I root 3. Okay. If you think you've got it, go ahead. You can pause at any point and try this out. If you want more help, then stick around. We'll do them together. So here I have root 50, negative. So the first thing I'm going to do is get rid of that negative. I'm going to say, all right, well, let's put the negative in its own little radical. Now I just have to worry about root 50. Okay, so let's use the ladder this time. If I want to ladder, I put 50 on its own little, nice little Heidi step thing. And I say, okay, what's the smallest prime number that goes into 50? 1 isn't going to help me. 2. 2 goes in 25 times. 2 doesn't go into 25. 3 doesn't go into 25. 4 is not a prime number, so the next one is 5. 5 times. 5. 1 time. I know I'm done. So I know that I'm going to have a 5 that comes out of this root 50 and a 2 that's stuck inside. From the first radical, the square root of negative 1 is I. So on the outside I have a 5, I have an I, and I have the square root of 2 who's left behind because he had no buddies. What we're really doing is we're saying, hey, negative 1 is really I times I. So look, here's a pair of I's. That I gets to come out as well. Anytime there's a negative, you're going to take out an I. It sounds terrible. Take out an I. Okay. $288. I'm going to be honest, I prefer to do the tree, but it is totally your call. So I look at this and I'm like, oh shoot, 288. Well, first thing I'm going to do is I'm going to rewrite that as square root of negative 1 times square root of 288 to get the negative out of there. But now I look at 288 and I'm like, shoot, I don't know what goes into 288, but I know that it's even. So if I divide by 2, I get 144. Now I can factor 144. I know that 144 is 12 times 12. And here's the cool thing. If you want, you can stop right here. Because I see a pair of 12s. I'm done. That's a perfect square. The 12s will come out. The 2 will be left behind. But if you don't see that, you can keep going. You can say, all right, 12 is 4 times 3. 4 is 2 times 2. There's a pair of 2's. 12 is 4 times 3. 2 and 2. There's another pair of 2's. And here is a pair of 3's. The only thing that's left behind is a 2. So on the outside, I'm going to have a 3, because I have a pair of 3's. A 2 from that pair of 2's. Another 2 from that pair of 2's. And an I from taking the square root of negative 1. And then the leftover that had no buddies is a 2. So now I simplify. 3 times 2 is 6. 6 times 2 is 12. 12I root 2. Remember how I said you could have stopped at 12 because you have a pair of 12s? Your choice. Okay, almost done. These are the same. They just have something in the front already. This is your coefficient. All we have to do when we have a coefficient is multiply it by whatever pops out of the radical. So in this case, there's no negative under the radical. That's great. I'm going to factor this. I'm going to call it 6 times 4. 6 is 3 times 2. 4 is 2 times 2. There's my pair of 2's. I already had a negative in the front, so I'm going to leave the negative in the front. 3 and 2 don't have any friends, so they are stuck inside. So I can write the final answer as negative 2 root 6.